We do now have a name that is probably worth mentioning.
Wild True Talk.
Nearly failed to say the while there.
Nearly. Wow. Wild True Talk.
What do you think of the name?
Well, I picked it with you, so I think we both picked it together. But yeah, I know I'm quite happy with it.
I liked our creative process around the name, actually.
Yeah, I can't remember.
Your sheet of words, basically.
Nerdy words.
Yeah, that's what it was.
I've had a lot of feedback telling me that it's too nerdy.
The name?
I think it's perfect because
the name is too nerdy.
Yeah, but I think it's perfect. I think if you're doing a podcast for programmery types like you, Philip, then that's what you want. Wild True.
I did have to explain to a friend of ours who we play PUBG with.
Oh yeah.
I said the name and he just was like glazed
blank.
And I was
he's a doctor.
Yeah, which is understandable. But I like the way it goes with the logo as well. But I really thought we'd come up with a really bad name and
yeah,
logo.
It would be terrible. It's gone better,
and it's gone better than I thought.
Yeah,
and then also picking the catchy jingle as well.
The jingle, which was probably the hardest part of this entire podcast process so far for me, listening to about 500 jingles, all of which were rubbish.
Yeah. And again, you just giving me a short list and me then clicking through, literally on, I think it was Christmas Eve, being like going through
listening,
just Pond 5 and all that stuff. It was just a nightmare.
It was a
nightmare. Hopefully it's okay.
Yep. Hopefully you like it.
But yeah, it feels a bit more real now, I guess.
It does. Now we have a name, and obviously the name is because we do go on a bit. So
yeah, you like talking.
Wild True, talk.
And it is now released, and we've had a few people listen to it, so hopefully we'll get some nice.
Find us in your podcast app.
Friendly.
You can leave us reviews on iTunes, Philip, if you want.
Can you?
Only nice ones. Yeah.
You're allowed to. It does actually have a review system.
Yeah, I think it does. Yeah.
Oh, right. Next we'll be saying we need a little Reddit subreddit so people can abuse us there.
Yeah, I don't know if I'm ready to open myself up to that level of abuse.
We've been there before and been burned.
I've been issued with enough abuse already from my friends.
Random
randos abusing me.
So last week's episode was a bit odd because we'd actually pre-recorded the main topic of that before, which was about programmer interviews. Is there anything you want to follow up on that? Or
I don't think so, no. I think having listened back, I was actually pretty happy with the end summary. It took us a while to get there, as is often the case, but I thought, I think that was pretty, and I had quite a few people say, that was kind of pretty much it. So it's solved.
Yeah. Solved. So you'd had feedback, people agreed with our summary, or?
By and large, yes, I think there was some feedback of perhaps they like to test them on a few different ways, like a few different languages or something. But which I guess if you had a job which required a few different languages, but that was it really.
Right.
How about you? What did you think?
Yeah, I thought I listened to it back and was quite happy with our summary, our discussion, I guess. But I mean, I was part of it, so I guess I have.
We're very happy with it.
Yeah, we're very happy with it. But no, I thought it was good. I thought, I think it comes across in the podcast my frustration with some of the classical interview techniques, and I don't want to, we don't need to go over them again. But I think the reason for that is just pragmatism, and I probably say that word a lot, but that's what I feel like. I think there's a lot of theoretical or high reaching goals that people want to achieve with these things, that at the end of the day you just need to get the job done. And we're not in academia, so
they don't always get to actually get people to join your company to program well for you. They don't always serve that goal. These very academic or strange whiteboardy things. But it is interesting because there's not necessarily the best feedback loop on interviewing. It's quite easy to be quite lax about it. Be like, oh, our process is fine, even if it's not.
The one thing I did want to ask you actually was, have any of the guys that you were helping find jobs listened to this and felt it was applicable? Or
yes, I think they did, and one of them is still searching. So
okay,
I don't know if he's listened though, but yes, I think they felt that was pretty much what they'd experienced.
Okay.
So I don't think I have anything else to add.
All right. Well, no, I think I'm good as well. Let's crack on. 2019. Big year of podcasts.
For us, yes.
So today you want to talk about testing,
Testing.
which is a big topic.
It is, yeah.
Where do you want to start?
I want to ask you if you write any tests.
It's a good starter for 10. In my day job, I don't write tests. And I think I mentioned this to you the other day. It's mainly because I haven't written a unit test framework for KDB that I like, because there is one and I don't like it.
Mm-hmm.
And I guess, yeah, I mean, that's the honest summary. Even core stuff, I haven't done it. What about yourself?
I don't either, so we can just end it there.
Yeah, job done.
Job done.
Don't bother.
Don't bother. No, I don't. And I have testing frameworks.
Yeah, you have no.
I do sometimes, rarely.
So this is what I was thinking, right? I was like, I don't write tests, and why don't I write tests, and when do I? So
Yes.
my open source Java projects that I have on GitHub all do have tests. And that's because they are libraries and I wouldn't say frameworks, they're not probably big enough to be frameworks, but they're libraries. And I feel like for that sort of thing that you're releasing, I think you need to have some tests. I mean, you're never going to hit 100%, right? It's pretty hard to do that.
Yeah.
But they all have above, I don't know, 40% test coverage or something to at least be like the effort's there.
It's, yeah.
Because a lot of it are like, utility functions and things like that. So I guess it makes sense. But I guess it comes out, I think then like application code. Do you need to test every little bit of it?
So there are some people in this world who... So part of the reason that I wanted to talk about this is because one of the people that used to work for me that's currently searching for a job mentioned that a lot of companies are basically judging him quite hard on whether he does TDD and whether he can write tests. And I realised when he was saying that actually, I think a lot of people in this industry, they associate writing tests and developers that write tests as being a quality developer. So if you don't write tests, then like,
you're a bit of a cowboy.
Yeah, you're a cowboy. The implication is like, ugh. And I think there's a different... I think both you and I can write tests and have written tests, but choose not to, which is perhaps a little bit different because obviously we're the highest quality developers. But it was when he said that, or when he was sort of implying that, I thought, oh, that is actually pretty true. And like a lot of companies, if you go there as a developer and they say, oh, do you write tests? And you say no, they're going to maybe judge you a little bit. Is my feeling.
Yeah. So there's two things there I'd want to say. First thing is, does everybody just say yes and lie?
I assume so. Right. That's probably what. If it was me in that scenario, then I would consider doing that. Yeah.
And the second thing is, it was that I was thinking about it then. I've never worked anywhere that I've even seen TDD be done.
So that's what makes me laugh about this is that when he was telling me, oh, I'm going to all these places and they're asking about tests, and I thought, how many of them do you think are actually practicing that? Or it's kind of like you were saying earlier on, like it's like this magical higher standard that they're all. It's kind of like wishful thinking. They're like, we really should be writing tests. When we interview people, we're going to check for tests, and then then the project really needs to get done. It's like, are we going to write into tests? No,
just get it done.
Just get it done with like half the way most of the industry works.
So yeah, that's the interesting thing, right? So if we're thinking about say you've got a massive application, you want to be writing tests. I would think actually that perhaps that should be part of the code review. Would be like. You let the developer make subjective decisions about which pieces he thinks need testing, and then you look at the code review and go, well, that's quite a core piece that we're going to say it's very reusable, or I don't know, something that is called a lot of times. You might be like, look, maybe we should write some tests for this. Make sure this add function is definitely adding up, because if this screws us over down the line, it's going to be a big problem for our bank. Say,
how many tests have you written in the past? Perhaps that's a better question.
Yeah, so at my second place I worked at after my big investment bank job, as part of that, I did write a unit test framework for the KDB stuff we did there, and I did try and write tests for all the core functionality that there was. But again, I'm being clear to mention core functionality because a lot of the business logic I didn't write tests for because I don't know, I just didn't feel like there was necessarily a need to. But it's hard now thinking about it. Again, it's quite a while ago justifying why I thought that at the time. But I was thinking more like core, functions that are shared across all of my applications that I had.
Yeah.
I'm like, well, I want to make sure that those have tests that I can validate.
So,
And sorry, just on the other thing then, but on the Java side, I tend to actually be a little bit better than that.
yeah.
I tend to be a little bit more aggressive at writing the odd test. Mainly and again, that it's more of a subjective thing. If I've written a function that I'm like, oh, that's a bit iffy, or somebody might want to change this in the future, I want to write a test to make sure it breaks because it's doing something that's not obvious.
Yeah.
Then I would write a test to protect the future developer.
I don't think about... God, that's very good of you, thinking about future, not even future you, future someone else. I like that. Future Philip.
Yeah.
I don't write them anymore, and I used to write them when I started my career. I don't think I really knew how to write them at all. Oh, we did learn at university, actually, in fourth year, half-heartedly.
I didn't feel like... I felt like I didn't really learn.
No, yeah. Then. That's how I kind of like knew they existed and had written some. And then I went through a period where I don't really read books, but I read or like... Because I can't remember who... Is it Kent Beck that's really into this? It's one of those guys. I think it's Kent Beck. He wrote a book talking about TDD or Feathers or one of those guys. And they basically have this... I've seen this video where he's like doing TDD. And he's like, first of all, we write a test. Then we write the minimal amount of code that makes that test pass. Yeah. Even if that code is utterly stupid. Like, it can be like you're writing a function for the mean and you say the mean of an array with just 1 in it is 1.
Yeah.
And then so then you implement the mean function, you say return 1.
Yeah. This is I do have problems with TDD.
And then you're like, okay, so now I've written a mean function which literally says return 1. So it doesn't work in any other case unless the mean is 1. Yeah. And then you're like, oh, I'll add the second test case, which is like 1,2, or like you just pass in 2, and now the answer's 2. And so then you can write like, if they pass in an array with just 1, and then at some point you write enough test cases that you just have to generalize the whole thing and write your mean function. But he takes it like crazy far. I think it's an interesting thought exercise.
So the problem I have with that is not a problem, but the way I think TDD has come about is that it feels like somebody's gone, you know what, we have developers writing loads of code, and for some reason none of them will write any tests after they've written it. So what happens if we just reverse that and make them write the test first, then write the code?
I think...
Because that does solve the problem.
Yeah.
But I don't think a lot of what you do when you're writing a function, because obviously the smallest thing you can test is a function, right?
Yeah.
You can't think about everything it's going to do until you've written it, I think. Because there's no design beforehand, right? You're not going in thinking, right, I know roughly what the function might do, but then I might write it, find that doesn't really work, and then actually change the way the calling function... there's all that sort of the linking together of those.
I think what TDD got right was if you relax... Well, so I don't know if TDD formally says you have to write the test first. I think a lot of people think that, but I don't know whether it does.
Okay, I didn't know that.
I don't know. I'm not sure. Maybe it does. But I know like a common interpretation of it is that you have to.
Right.
I think the idea of writing tests close in time to when you write the code is a very good idea.
Yes.
So you don't want to write some code and then 3 months later be like, now we're going to test it.
I agree.
Reason number one for that is that if you're working in a real company where they have like programmers which they fondly name resources and they are doing resource management, then you say, well, Dave, I need to go and write those tests for that code we wrote 3 months ago. Never going to happen because they've got a million other things they want to do, and what's the point in it? Like already works, and they've all forgotten about it. So that's reason number one. If you're looking just like kind of like a human hack, and the other reason is that like, actually, I think that's probably the main reason. I don't know if there's I think it kind of helps because you just wrote the code.
Yeah, you're familiar with it, right? And you know in your head, these are all the possible outputs of this function.
Yeah,
right?
Inputs and outputs, yeah.
So then you can be like, well, I'll just write them down. Like when I write, if I'm being really thorough, particularly for the framework or the library code that I've released, I'll be like, right, I'll have like null checks that throw a legal argument exception or something if you pass those in. I'll write a test that will just make sure it throws that. Because you get the coverage, which is, nice. And it's just, it just means that you've thought through every single input and every single output.
Yeah.
If the input is null,
covering those. So that's.
But I'm not advocating doing that for every line of code you ever write.
Yeah. So the main thing with testing that I wanted to say is that what's changed. So previously in my career, there was a period where I basically mandated that I had over 80, often over 90% coverage when I was writing Java on everything I wrote.
Yeah.
And I think my team at the time, I was quite early on in my career, first couple of years after university, I think they thought that I just properly lost my mind. And I built this system for my boss at the time, and the deadlines were quite hard to meet. And I was like, no, we're gonna do this properly. So I tested everything, and I had to work evenings, weekends,
to get it done.
Because I was writing all these tests. I did ask him in the pub a couple of years later, and he said that system has actually just never broken. So maybe it does work, but I think the thing that's changed that I've twigged. So when I went to my job after that, I was still writing quite a few tests, and I went to a team that didn't really write any tests. They didn't have any builds at that time, so I kind of added that and was like, oh, maybe we should write some tests. But then the thing I've realized over time is that just from I don't know if business perspective, but just common sense, if you write some code that does a thing, say you write a function that calculates the mean, it's an average, that might take you can't predict because it's software, but it might take you 20 minutes to write. Say, probably, hopefully not, but 20 minutes. If you write some tests to accompany your mean function, that's going to take you 20 minutes plus some extra amount of time.
Yep.
So the first thing you need to think about when you're thinking about this stuff is that tests are not free, because when you write them, the asset you're delivering as a programmer is not just a function that does a thing. It's a function that does a thing and the tests that say that it does that thing.
Yeah.
So you're delivering more stuff. So anybody that's I want a developer to write tests and implementation code, and I want them to do it in the same time that they could just write the implementation code, that just doesn't make sense, because they're delivering
more.
They're delivering more certainty.
Yeah.
And as with all things in life and business, there's a trade-off there.
It's a risk assessment, I guess.
Yeah,
to some degree,
it's like a risk assessment. The cost is higher, and so then you have to think about if you've got your actual code and the test code, what is the test code giving you?
Yeah,
and I think it gives you more certainty that code works and does what you said it should do.
Yeah. Assuming the developer can write good tests, which is a separate problem.
Yeah. If you've written some good tests, then you can be more sure. There's a high probability that function does what those tests say, and hopefully you've written good tests.
Yeah.
The second thing it gives you is that the developer can change that code and then be more sure that it still works.
Yeah.
Which in certain scenarios will speed them up in the long term. So you're like, oh, we need to change our mean function. You can just go in there, aggressively change it and go, yeah, it probably still works. Whereas if you hadn't, you might need to do a bunch of manual testing, and manual testing also takes time.
Yeah.
So I think those are the main sort of two things. I think there are other things that tests can do for you as well that I've forgotten.
There's a couple of interesting points just there, though, whilst we're on that. I was thinking it's probably quite mean, but you could do this. So you could say, I'm the developer writing the original average function, and I'm not going to write tests. But at the point where we need to make any change to it, we then need to write tests to test what it did before, make the change, and then test what it did afterwards.
Just-in-time testing.
Yeah, but obviously that fails your other point, which was you should write them close to the original implementation.
Part of the reason for that, so part of the reason that I think that it's an interesting, I've never thought about that idea. The reason that idea might not work in practice is that depending on what language you're in and how you write the code, it's possible to write implementation code that is not easily testable.
Yes.
So you might write your average function and then be like, oh, we're just going to just-in-time test it when we're going to change it 6 months later, and then go, but I read from the console, or I don't know, you did something weird with state, and now, hopefully you didn't do that writing an average function, but you can't be certain that you can test it. The only way you can be certain that you can test it is to actually test it.
Yeah.
Or you can sort of reason about it in your mind. And so another thing...
Yeah, that's true though. That's a really good point though, I think, is that you're saying, if you're writing tests, it's going to affect the way you're writing your actual deliverable code or functionality code, right?
What do you think about that? Because that was one of the things I was going to ask you in this discussion. Sometimes you're like, I'm going to write this code like this, and then if you, say even 10 minutes later, you go and retrofit the test, you think, especially, it depends on the language. So if you write what I call pure functional code, which is where you have a function which takes some parameters and produces an output, and the only thing that affects the output is the parameters. So if you change the parameters, the output might change, but they wouldn't change because like the time of day was different, or they make a network request and that returns a different thing.
Yeah.
So they have no outside. It's just the stuff that's coming in is the only thing that influences the output, which is like, I think that's sort of roughly the definition of a pure function. Then you can pretty much always test those things.
Yeah.
It's easy. You put in different inputs, you verify the outputs.
Yeah.
But it's quite easy to write things where you can't, like that's not the case. And then it's very hard to test because now it's going across the network. And if the network goes down, they fail. It's also in certain languages to do with like, you know, keywords like private and public. If something's private, you can't really test it. And it might be something which makes perfect sense to test, but it sort of should be private because nowhere needs to access it other than the test. And some languages like Java are not very good at bypassing those controls. It's quite hard. So then you just end up with make it protected or make it private. Yeah. Just so that you can get hold of it. What do you, so like, I'm sure we've all been there, but what do you think about reshaping your code?
Yeah, I think if you decide, assuming that you're making a conscious decision when to write tests or not, and you know, you then need to decide. You've decided that this function needs to be tested for whatever reason. Like I said before, it's quite hard, it's quite complicated, and you feel that it should. So I think you should manipulate your code to be able to do that. I agree, though. Like with Java, there are those complexities there where you're like, well, this is a private field,
and it should be private.
Yeah. But I guess, I mean, for me, probably the way I get around that is just have a public getter or a protected getter.
Sometimes it's like if you have a private function,
yeah,
you're like, it really can be private, except for the test, where it would be a lot more convenient if it's public.
Yeah, I think. The way I maybe get around that. So generally, what I do there, actually, in that case. Because when I'm thinking of tests, it's coverage of test code. So if there's a private function, there must be a non-private function somewhere that's using that private function.
Yes.
So I would probably just test the public function. Because assuming that you can test the flow of the private function based on what you've passed the public function, then you would probably be okay.
So you definitely could do that, but then what if the public function has like some crazy state and calls a network? Then you're kind of like
then it gets hard. And then we have to talk about mocking objects and stuff, right? Which then gets quite difficult.
And then like there are like whole patterns of writing code, especially in Java, because of the nature of it, where you're passing like, you know, like dependency injection stuff, and you're passing all of these other bits of code in, so that sometimes when you call them, you can pass in a mock which behaves differently when you call it just for the tests, and so you really end up like
if you're thinking like if you're using Spring or something. Yeah, I've used Spring test as part of my JUnit and mock test, where you basically give it a configuration to be like, well, when it wants this bean, actually just give it this mocked version. And things like that. And it does work quite well. The only issue there is it really bloats your test code.
Yeah.
So your test code can end up being, like, for a relatively simple piece of functionality, you've got like 100 or 150 lines of code, you've got like 60 lines of, I need my Spring to boot up to run this test. Then it runs, and then you've got 8 or 9 tests, and then you're like, well, that's actually a hell of a lot more code than the actual underlying function.
Yeah, than the actual implementation code, which is another thing. So I think, going back to what the guy that used to work for me was saying, part of the reason that this is considered a thing that interviewing companies are looking for is because it's pretty hard. It's tough, and that makes the trade-off of like the return on investment of writing tests is difficult because the tests are so expensive to write, and in some cases they can actually they can take more time.
Yes, that's what I was going to say. Yeah.
So it's not like you're like, oh, let's say that like writing some implementation code is going to take an hour and adding the test is going to take 5 minutes. That ratio, it sometimes will be the case. If you're writing a function like an average, it should be really quick. But if you're writing pure functional code, depending on what it is, that ratio could be pretty good. It could be like I spent 1 unit of time writing the code and like 0.2. So you spend a fifth as much time writing tests. But very frequently, it's like a ratio of 1 to 1 or worse. Like you spend the same amount of time writing the test as the code.
Yeah.
You spend an hour writing the code and then an hour writing the test. But sometimes, like in that example that you just gave, it's going to be like 1 to 2. It's like you can write the code in like 5 minutes and then you'll spend an hour being like, how do I mock like a whole really bunch of Spring thing? And it gets really difficult. And the return on investment calculation becomes hard because the cost of writing tests is very material, And the benefit it brings is there, but like it depends. You have to factor in that cost. I think people that think about this wrong, they don't think about the cost. They kind of just magically assume that
you'll have some tests.
Good developers write tests, so tests will just be there, and tests will be built into all the estimates. Well, the reality is that they are there, and there is a cost. And if you were to pit that developer against me and we're racing, and I'm not writing the test, I'm probably gonna smoke you.
Win.
Yeah, I should win.
Yeah.
I don't know. It depends what kind of day I'm having, but I should.
But there's a thing about the testing there as well that I mentioned, because then I was talking about the spring stuff and mocking it. It then becomes, as part of your value, deciding how much value is and return on investment there. I have done, and I think I have done in these open source ones, anything that's just a bit too complicated to test, I just haven't tested.
Veto.
Because I'm just like, I'll just do the 50% of this code that is easy, relatively easy, and the ones that I know, like, this could take me an hour or two to write a test for, I'm just not going to, I just haven't done it.
Just take the easy bits, get them done.
Because I still think having some tests is better than having no tests, even if you're missing the more difficult to test bits, because it means at least there's something there that you've reasoned about and double reasoned about by having to write the tests.
Yeah.
So I think it's better than none, but I also appreciate not having any at all. But the implications there are, at some point, it might come back to bite you. Yeah. And then you have to think about, well, what are the chances of this code actually being changed?
So everything in with tests, and a lot of software actually, which we're probably going to end up speaking about more, is to do with future probabilities, which is what makes this discipline of coding is hard. Because when you're thinking about whether you should write a test, you're like, what's the probability that we're going to change this in the future? The higher it is, the more the pendulum swings towards maybe it's worth writing the test, because there's a lot of uncertainty here. I know my manager, Dave, might change his mind on this, whereas some other thing, you're like, well, they're never going to change that. So it's like, what's the probability of it changing? What's the cost if it breaks? So like I wrote a function once which like nets amounts on trades and decides, we'll take like 5 trades, some of them with a positive amount, some with a negative amount, and says, it was like +5 and -3, so we can just do 2.
Yeah.
You do not want that code to go wrong, because someone is going to get very annoyed with you.
It's the wrong way around.
It's like, actually we traded 100, or we bought the wrong number of shares or whatever. It's like that's something I would test, because you think, how mad would someone be, or what are the business implications, or how much money would we lose?
Yeah.
And what are the probabilities of that? Because like it may be that like there's a very low probability of losing a lot of money, or it may be that there's a average probability of losing a bit of money, and you're kind of like, it's kind of like insurance or something. You're like thinking like, is it worth writing these?
Yeah, I think that's always a problem with tests, and it's very easy to just not write any, because at the point where the program works, you're done, right? You can. It's very because a lot of business people, or the person you're delivering to, doesn't really think about tests.
Yeah.
They might be like, you're doing testing, right? And you're like, well, yeah, when I've written this function, I check that it compiles and runs and gives me the answer.
It works, doesn't it?
But then you're like, well, that it's fine, it's done. My job here is done. You've got to explicitly be like, well, no, actually, I said it'd be done by 3 o'clock, but give me another couple of hours just to make sure let me test it some more.
Yeah.
But when you get into complex applications, even just testing the application, i.e. by running it and watching its behavior, becomes quite time consuming.
Yes. That's another reason to write tests, is that manual testing, especially if something's repetitive, we wrote an app recently for a startup, had no tests, and every time we released it, we had a big checklist, which is quite a common thing.
Yeah.
It'd
be like a QA.
Yeah, QA
job, right?
kind of like, open up the app, log in, book, whatever. And then you're like, oh, and then it gets to the point. My first job, we used to develop for a month, and we used to spend, the whole team used to down tools for 1 week to just test the changes we'd built in the other 3 weeks. Yeah. So for every 4 weeks of development, 1 week just went by the by, which I think when you're getting to those kind of ratios, you think, how long would it take to write, to automate all of this stuff? And maybe it's not unit testing, maybe it's
integration
testing, which I like those things. I like them more as I've got further into this game, actually. Unit testing's cool, but actually I do really like just being able to like have like a more of a splatter, like I did loads of things that are actually an end user's doing and it all seemed to work, gives me quite a lot more confidence in a way than like, your mean function definitely works. You're like, well, what does that tell me? Like, it tells me.
Yeah, exactly. Yeah. So, if it's a web API, right, you probably have a cheat sheet of URLs that you're going to hit. Yeah. And you can see whether you're expecting a result back. That kind of thing. Right?
And you can kind of like 80-20 it and you're like, well, what's the, and you can, when you get more experienced, you can think, what code did we change? What's the probability that these things are going to be broken? And you can mix a bit of automation with a bit of manual testing. And
so that's another interesting point, right? Is that if you're writing an application, like me right now at my work, I own the code and I'm the only person that develops it.
Yeah.
And I've written it all. Mm-hmm. So it's like, well, the only reason I'm writing tests then is for myself.
Yes.
So the value for that, I think, is reduced. Whereas if you're in a team of, say, 3 or 4 or even 2, then you're writing a piece of code. Adding the tests there makes more sense because it's, I don't know, I think maybe I'm thinking of I think of tests more as for other people rather than for myself.
Some people say, I learn how the code works by looking at the tests, and I think those people are mental.
Yeah.
I don't, that does not, occasionally it will help me, maybe in like really pure functional cases. But like normally, if I want to see how something works, I'm going to look at how it works. I'm not going to look at something that like.
I don't think I've ever looked at any other code's tests before looking at the code.
No, you always look at the code. You're not. I don't derive much meaning from like this thing, which is like executing it and verifying things.
But like you download things off the web, right? And they're like particularly on the Linux side, where they're like, oh, you can make it, you build it. And then you can run the tests before you install it. You do like make, build, make, test, make, install. Mm-hmm. I was just like, well, I'll just save time and not run make, test because I'm assuming that all these tests work.
Yeah.
Because I'm not the person that should be responsible for checking that all those tests work.
Not my problem.
Yeah.
I suppose there are other benefits when you're working in a bigger team, like you say. Stuff like having tests and then someone checks in and then continuous integration. Like they push some code and then continuous integration runs and says, hang on a minute, it looks like maybe you've broken something. That could potentially save you a lot of time rather than that thing just silently being broken.
Until you're doing your integration manual tests and you go, oh, well, that's weird.
That's weird. Why is that broken?
You've completely lost context of what you're changing.
So it keeps the feedback loop between like I changed a thing and I broke a thing much shorter, which is a good thing. And like it's going to make people more productive. However, there is the other case where someone makes a completely legit change to something which has not changed any functionality in the real world and it fails like 3 tests. Yeah. And then it becomes a burden. But
then I would argue that's a bad test.
Yes.
So we had something like that. So we use SBE, which is a messaging format, like Google Protobuf.
Yeah.
And someone had written a test that validates the output, the binary output of this SBE, because it's a binary encoding. So you give it a structure.
Yeah.
And then it builds literally
ones and zeros.
Yeah.
Yeah.
So somebody has validated that, but one of the fields that it's automatically given is a version.
Yeah.
So the version was changing.
And so then the different ones and zeros because the versions...
And they'd hard-coded looking for 36 and someone had upgraded the version to 37. Right. And then you're like...
That's a bad
all these tests have failed. Yeah. And you're like, well, why are we checking the version?
Yeah, that's
a bad test.
But right, to be fair to that, like anybody that's ever written a bad test, they're hard to write.
Oh, yeah, no. I'm not saying I write perfect tests, but it's clear at that point the test... that the issue there has become with the test and not with the underlying code.
But that is quite a common case in practice. Like in an ideal world, you're like, oh, everything should be fine. But quite often when a test fails, sometimes it's because I would say actually, in my experience, the percentage of the time the test fails because the implementation code there's a bug with it, compared to there being some sort of problem with something to do with the testing, that ratio is like... Yeah. Is probably somewhere close to 50-50. Like I would say a lot of the time it's like, oh, we changed this other thing and the test has failed because like the kind of infrastructure and the way that the tests are done, whether it's like mocking or something else is broken. But the actual thing, like you said before, you've got 60 lines of code like setting it up to like get in there to write your small 8 tests.
Yeah.
The small 8 tests would still be fine. But something to do with the setups, something to do with the setups changed. I think a lot of that is to do with languages. Like I think part of the reason that I like functional programming, even though I don't really write many tests, is that I wouldn't say I don't write any tests. I do write some, but I really pick and choose my battles. And we can talk more about that in a minute. But part of the thing, I think if you write pure functional code, so like stuff comes in and stuff comes out, then testing is in general, it's the easiest type of test you could ever hope to write. You can say, I put this in and that in and I expect to get this out, and it's not going to go wrong realistically. Whereas when you get to more state things, like kind of, we're accessing a database, it gets really hard.
Then you'd argue that, those simple functional tests, like you were saying before, you're writing your average function, it's pretty easy to reason as to whether that average function is working or not. So should you even bother writing tests for that and actually focus your effort just writing tests on the more difficult pieces?
So another thing which I think in the way I think about it is like the cost of writing tests, like you already basically said it, that some things are easier to test and some things, like you were saying, this is going to take me like a couple of hours. So the first thing is the variable of how much does it cost to write the test? And then the other side of the equation is what's the benefit? And we said probability that the code's going to get changed.
Yep.
Guess how big a team you're in, because basically developer productivity, being able to check some code in and having CI fail is like a good thing.
Yeah.
If the code goes wrong, what are the consequences and what's the probability the code's going to go wrong? Losing money or someone dying. I don't know in which order. No, probably someone dying and then losing money. I said that way around. It's just the way it came out. But yeah, someone dying. Yeah, or losing money, more importantly. Yeah. then you probably should write some tests. Whereas if it's just like you said, you work in a code base, you've got some little function you're using. If you screw it up, you're going to get an error. You're just going to look at it and go, oh, I messed that up. You're just going to change it. There's not really any... It's also, will that error be at dev time or prod time? It's something I think about. Like if it's going to be at dev time, like if it's going to break and it's going to send everything to a screeching halt, but realistically, it will only ever happen in dev, like when you're working on it.
Yeah.
Like, who cares? Like, for example, you pass in like the wrong type. Like, is there a point in writing a test because someone passed in like null? It depends on the function and the context which you're calling it. But if you're only ever calling it with other code that you write with your own hands, when you write that code, you're going to call that function and it's going to just break and you're going to go, oh, yeah, that was stupid. Whereas if maybe the input's coming from an unpredictable source, maybe it could be null. Then maybe you're like, oh, maybe I should test that because it will wake me up at 3 a.m. Whereas the other one, you're just going to go, oh, I've messed that up. So
I guess the interesting thing with Java is another potential way around it is that you could just say, I'm not going to handle any error cases from my side, and I'm just going to throw those back up to the caller.
Yeah.
And make the caller deal with it, right? Mm-hmm. So there's obviously if that's one and the same person, you're not saving yourself any effort, but you could make a lot of issues in Java come from unchecked what do they call it? Runtime exceptions, right? So they just get thrown. You don't have to explicitly catch those. Whereas if you go, you know what, something weird might happen in here. I'm going to write a custom normal exception that you're going to have to deal with if this doesn't work.
Yeah.
There's definitely a reason for that. And then you're saying, look, I'm just going to, all I'm going to do is test that in the case you pass something stupid, I throw your stupid exception.
I tend to go that way.
Yeah.
Because there's like a saying like, crap in, crap out.
Yeah.
Well, that's maybe not the saying, but it's similar to that, and with different words.
Yeah.
But I am very much with a lot of things. I'm of that mantra, especially if you own, like you say, you own the code and you own the code that calls the code, and you're the only person. Because I think that really, like you were saying, where you test your libraries, I think that's another thing that I consider. How many other developers are going to use this code? Like, am I building a library that's going on GitHub that like 1,000 or 10,000 people, like Lodash in JavaScript is like the sort of standard general purpose library we discussed like a couple of episodes ago.
Yeah.
They should write some tests for that because like probably 10 million programs are running using that stuff. And if there's some dodgy edge case, someone's going to bump into it.
Yeah.
Whereas like if you're writing a function and using it in one context, is covering all the edge cases that important? Probably not. And I think as well, like, as I've got older, or not older, but as I've got more experienced and unfortunately older, I think I've come to realise if you have a problem with your code and you can fix it quickly, in a lot of contexts, that's okay. Like, that's all right. Like, you're like, oh, that thing broke, but now it's not broken anymore because I just changed some code and deployed it. When I was early on in my career, I was like, that's cowboy. I've got to try and cater for all the cases as they happen. But I think it depends on who you're working for.
Depends on the kind of application as well. I guess anything other than small projects aren't going to have that ability, right?
Yeah, it depends how quickly you can deploy things.
Yeah.
So like smaller companies and smaller projects, you can just go blip deploy. But
I guess actually, to be fair, that comes down to a lot of how good a bit of a buzzword, but how good the DevOps side of stuff is, right? If you've got a great build pipeline where you can commit, merge, test, CI, and get it out within, say, 30 minutes, and that's a legitimately approved process that works every time, i.e. there's no exception, it's not like an exception route, it's just that's how normally you deploy stuff, then that's, there's definitely something to be said for that, right? Because you can say, well, look, we've got the ability to, our API, we can roll that out within 30 minutes. As long as there's somebody senior enough approves the code review and says that's okay, then, you've got that in your back pocket, right?
Yeah. And it means that you can be a little bit more cavalier, perhaps, than somewhere where it takes like a day's worth of testing. Although that said, almost every organization has a backdoor for when everything breaks, because if you didn't, you'd just have so much downtime that, it's like, oh, that's broken. Oh, emergency patch release where someone SSHs onto a machine and starts
release it before you get approval and stuff like that.
Yeah.
I guess the you want to make that, the problem is if that became the norm, that would be a very bad sign of how a team's working, right? So then you'd hopefully as a manager be like, look, we're obviously trying to deliver too much in too short a time and not doing enough testing. And then that's a procedural thing, right? You need to change the way the team works.
Yeah.
At that point, you've got to do less work or to have increase your estimates by. It's interesting you were saying before of the 4-week cycle, you're spending 1 week testing, right? So that's 25% of your effort is going to testing, right? And that sounds like a lot.
That's a lot, yeah. I think it was enough to make me consider jumping off the roof of the building that we worked in. So it's not. It was too much.
And during that week, was that a week to write tests, or was that a week to do like manual integration?
There were a dozen Excel sheets for different parts of the app, and you had to run through. Maybe we had in total about 300 manual line items that someone had to do.
And between you all in that week, you had to achieve.
You had to get the 300 done, and we had people like offshore people who took the brunt of it and put a brave face on it. But when I had to do it, I was like, I'm out.
This is awful.
I think I got to a point. So in the end, what I did was I not lost my temper, but I basically automated as many of these, the difficult ones especially, at a system level. So it's like it would open the app and physically click things. So it was basically whatever we were doing in that spreadsheet, we could just run a thing. And it was still kind of manual, and like someone actually had to run it on a physical box, but we could nominate a person and be like, Jack is just going to run that script and babysit it. And Jack's doing it, but the rest of us can do whatever the hell we want. And we did tell our management, we weren't like, we weren't going behind their back. They're like, it's another week of testing. We're just at the bar sipping martinis.
And then what happened if like day 4 of that testing, you found like a critical bug?
Then we would write some code to fix it. But we had like a lockdown, or maybe on a branch. It was actually pre-Git days. But
then you wouldn't have time to do all the tests again then?
No, yeah. And so some releases... So obviously when you've got like... I don't know how many man hours that is, but it's a lot of man hours. Like a whole team. It was a team of like 7 or 8, maybe 10. So it's a lot of people.
400.
Yeah, like it's a lot of hours, yeah. I mean, maybe it wasn't a full week. Maybe it was like 3 days, but it was a lot.
A long time, yeah.
But we would get, what they would do, the more senior guys in the team would say, well, we've changed this bit and not that bit, and no one's touched this whole thing. So we're not really, we'll just like, say like I can't remember what the system even did, but like, say we're going to book a trade in that part of the system. Yeah. We'll just book a trade. Trade goes in. We're not going to test all the bells and whistles. Like, does it still sort of seem to work? Yeah, fine. And then other bits that you changed, it would be like, and of course you've got to update the document because you've changed stuff. Yeah. So now the document's wrong, and it was just.
Yeah, there's something interesting there, right? Is that you're saying it's having that intelligence to be like, well, I'm 1 or 2 or 4 people understand the system enough to know when you've changed bits in certain bits of the repository that impacts certain things, right? But that's never written down, and that's the bit that I think if you could somehow put that into some sort of document, or even if you could automate that in some way, so then that some tool could go, right, since the last release, these things have changed, which impacts these things. That means this subset of tests should be run. That'd be amazing.
I guess it comes down. I guess as part of that's like architecture and the way you deploy. Because if you keep things really separate, like you have separate APIs and a separate UI, you can be like, well, we haven't actually committed any code to this thing. But then,
I was thinking like even like a very fine grained level.
More fine grained, yeah.
I guess microservices would help with that because then you could say, well, we haven't. There's no commits in microservice A, so we're just not. It must work.
It's still.
The problem is because we have a lot of individual processes. I wouldn't say they're microservices by any sense, but we have a lot of moving pieces. The problem is that you've got a flow of data, right?
Yeah, through one to the other.
So then if you break the top one, or the top one's changed something, then you've that everything flow. The whole system doesn't work, and I guess automated integration testing is something I've never really seen or done.
No, I've not. Other than that, which was sort of semi-automated, I've not really. I've read about it. I'd imagine if you're someone like Netflix, something like that would be amazing. But
they must have something like that.
Yeah. Because I guess the thing is for someone like Netflix or Google, again, it comes down to what is the cost if the code breaks. And if they have an outage, like Google never seems to have an outage. If they have an outage, it's bad news. Yeah. So having a thing which physically, like investing the time, like getting 1 or 2 developers and being like, you've got a year to like test the crap out of this. That's totally worth it for them because it's so little money compared to their bottom line. But now they can be more confident that things aren't breaking. But when it gets difficult, it's like someone has a budget, and they've hired 2 developers and, they've not got a ton of money.
You can't say to one of them, you just do testing.
Yeah,
the guy's going to deliver.
You can't, Or if you had 2 guys doing testing, that's all the guys. So no one's or girls, and no one's writing anything. So
I think, I guess now we've got things like Docker and cloud services, which actually make building a set of servers or whatever together to be able to replicate your application a lot easier. Say you've got 10 processes, you're like, right, we now have this. We don't necessarily use Docker in production, right? For whatever reason, but you could easily replicate that into a testing environment where you go, literally what we do is we press play, it builds everything up, everything starts up, and then you just need some sort of special testing process which can somehow trigger events inside your application, right? And if you could do that, and then literally every time you do a commit or every night or something, it goes, right, we span this up, we push through, say, a new market data quote. Yeah. What did our system do? Did we generate a new quote out the other end? No, it blew up. Something broke. Yes, it did. And then it it was within some value of the original quote that came in. You could say, look, we can validate that. But I don't think I've never worked anywhere where somebody is assigned to coming up with like a testing infrastructure. I suppose you call it testing infrastructure, right? Yeah. I've never seen any company that I've worked in that's gone, we have these people whose job is to make your application easily testable.
I'm a big believer with a lot of things in software that the same people that write the code should do all the other things to do with the code, including testing.
And releasing.
Yeah. Which is kind of what this whole DevOps buzzword was about. It's like, well, kind of or not. It's like rather than having a separate operations team that deploys things, it's got easier, like you just mentioned. So now we're just going to put it back in the hand of developers. And I do think the same people should do all the things, because otherwise you end up with this weird, I've had jobs even quite recently where there's a testing team and I find myself being like, well, they'll just, I'll just do something and they'll find the problems with it, and then it will get sent back to me if it's not good enough. And it makes you more sloppy, and you're not, even if you're not writing tests, you're kind of just, when you're checking your own work, like by physically clicking through the UI you've made or something, you're just like, well, it'll be fine.
I think an interesting thing that is around releases as well. I know that's not really the topic of discussion here, but it's really interesting. At the old place, the first place I worked, where we didn't do, there was a period where we were doing releases, and then it got taken over, and then we took it back because it kept failing. Yeah, they kept having problems, but the reason they were having problems is because our release system was awful. Yeah, like we were like, this is how you release something, and reliably the offshore team would get it wrong. Yeah, and they were like, oh, damn offshore team, came back to us, and then we were like, well, this doesn't work.
Yeah.
It was like, well, yeah, and that's what the feedback was always, that it doesn't work. But because it was an offshore team, our team were like, oh, it does. You guys aren't doing it right. It's that thing. It doesn't. You don't take the responsibility necessarily because it's somebody else doing it. Yeah, and bringing it all into the same team. You're then very motivated to make your release process better, your testing process better, because it's you guys that are affected.
Yeah, it's like when my first team, when they made us test the application, I lost my mind so much that I spent weekends and evenings to automate it because I was like, I physically do not want to do this anymore because I'm spending maybe a fifth or a sixth of my working life doing this, reading off of a spreadsheet, this really boring task. So I think,
and that's where things should be automated, right? But the interesting there is they didn't from day one go, right, how the hell are we going to automate doing all this stuff? It grew organically to a critical point. And then somebody was like, I mean, it should have probably been the other way around where they went, let's put some time and effort into automating it. But in your case, obviously, it was you just getting frustrated with the process. But again, it's a pragmatic approach to doing this kind of stuff, right? You're not on day one going to go, right, let's have this automated click-through of a system. Because right now we only have one test, which is, can you log in?
Yeah.
It's when you've got 300 of them, and then you go, well, maybe we should spend the effort. I know, and then some people would argue, well, you should do little bits at a time, and then you have it at the time you've grown. But again, it's back to your risk assessment of the problems and your return on investment.
It's very hard because the costs can be quite significant, and the benefits are... It's not like there's just one benefit. Like we've just discussed maybe 3 or 4 different benefits, like developer productivity, the risk of like something going wrong and you losing loads of money or someone dying or something really bad, or having an outage if you're Netflix and losing market share.
Yep.
Like that's bad news for them. There's like all these different risks, and it's kind of like, how big are those risks? How much money or time or will they cost, or how will they affect morale? I mean, morale's probably a legit thing in this as well. Like having everything automated is better for developer morale. If you want to retain staff, then,
as long as you can trust it.
Yeah, as long as you can. But I mean, in general, computers are probably in some ways better. If you're going to run, if you're going to release every 3 days or something, you'd probably want a computer doing it because a human's going to get sloppy. But
so an interesting side point actually, which, as you mentioned, Netflix again made me think about it. I'm sure I have read this before, but I'm going to be hazy on the details. If you're thinking about your impact to your customer, if you have a critical issue, another way that you can go around doing it is to say, well, actually, how do we build our production system just to be more resilient to these sorts of issues?
Yeah,
unknown problems with the code.
Yes,
that we can't foresee.
Yeah,
which I think is how Netflix.
They have a thing called Chaos Monkey, I think it's called. Yeah.
So I think from my understanding of it is that they obviously highly distributed all across. They do use AWS, I think, and they have however many servers, and they have this process which goes around actively just killing things off and breaking things,
just messing stuff up,
just to see. But this is in production.
Yeah, all the time.
They're breaking stuff all the time to make sure that everything stays online. And I assume they're running that in test as well. But it's an interesting side point. If you go, well, actually, tests are quite hard to do. And, okay, that part of that is verification, but also to make sure that when it's released, it works. And to make sure it works correctly. Maybe you think more about, well, if we just make the application resilient to these sort of errors, i.e. rolling releases or... some sort of better recovery mechanism.
Yeah.
I mean, the way Netflix do it, I think, is they stage the release, right? So they'll be like, you run it with 10% of users, this new feature for a week, and you go, does it work? Yeah.
Yeah, you're right.
20, 30, 50, 100.
Yeah, you're right. There are other things you can do. Being able to roll back is pretty neat as well. Easily. I mean, everyone can roll back, but you don't want to be sat there going, how do I roll back?
Yeah.
You just want to run a command and
click a button or something.
Yeah.
But I guess in those situations where you need... Because the reason that I think, for me anyway, a lot of the reasons why I don't write tests when I'm writing applications is because the easiest... Not necessarily the easiest, but the most complete way to test is to literally just run the end product.
Yeah.
And see things happening in the end product, right?
Well, it works, yeah.
Yeah, so from that point of view, thinking about Netflix, they can go, well, are people getting this data? The easiest way to validate that your flow is working, like you're loading the data, loading the video off disk, streaming it, is to release it to a small set of people
and see if they
can play. And I guess another part of that resiliency is then making sure you have a very solid error reporting mechanism back from your clients, right? So if you've got a web API, you need to be making sure if there's a 503 or something there, that you're immediately alerted to it or alerted to it. I guess immediately in that situation, right?
Yeah, I guess there are other things that they've moved to like another level of mitigating some of these risks through like deployment and infrastructure, and checking analytics to see, hang on a minute, in Brazil no one's watching any videos anymore, maybe there's a problem.
Those sort of things.
Those kind of things.
But I wonder, assuming that developers don't like writing tests, which I think is part of the problem, I feel like, for me anyway, I don't particularly enjoy it.
Yeah, I think it can be quite unrewarding because different people are different. The reason that I think both of us got into this game before we even learnt to code, and we were just presumably a couple of nerds, although I've basically learnt to code when we met each other, is that you like making stuff happen and the computer do things for you. Mm-hmm. That's a big part of it. And writing tests is not that. By definition, you'll do the bit that's interesting, that someone cares about. And a lot of the reason that I like working on products and projects and coding is that I'm doing a thing that someone in the real world really cares about. And I'm like, hey, Marjorie, I don't know why I put the name Marjorie. Hey, Marjorie, here's this website that you wanted. Marjorie.
You have run with that name now.
Marjorie.
I thought you were going to say Margarine.
Marjorie, as it happens, Marjorie doesn't care if I wrote tests. She just cares that it works. And and at the end of the day, most business people, or even if you're an entrepreneur and you're writing your own code, you're probably not going to write tests there because you get down to brass tacks and you're like, is this worth it? And this brings me to, I think, a lot of the calculation for writing tests when you're thinking about, if you're working for a company, so say you're permanently employed or you're a freelancer, it kind of depends on the stage of that company, how many customers they already have and how much money is flowing through that system. And also how much those things, but in the future. So if you're building a new system for a big bank and they're oh, you're building our online banking system and it's for I don't know, Barclaycard, you can assume that some people are going to use that. They're not using it yet, but there's some people going to be using it. So when you're building it, you think, well, hang on, when this goes live, what's the risk of if this all goes wrong? And you're oh, pretty high. If you're because they kind of have a thing which they know that people are going to use. And it may be that you're building an internal system for an internal customer and they're oh, the guys in accounting are going to use this. It's going to get used. Yeah. And that if it breaks, you kind of can figure out the real world consequences of that. But where it's different is with startups and smaller companies who are building a product and they don't really know that they don't know that they're going to get product market fit and that people are going to start using it. It may take off like a rocket ship, or they may get 100 users. And so in that scenario, in my opinion, in 95, maybe more % of cases, the right thing to do is to not write tests because you're going to write some code and then go, actually, the thing we had in mind to build in the first place, the product, is not right. And we need to bin that bit and change this bit. And if you'd have written tests, it would have taken you, say, 1.5, 2 times as long. And now you're throwing half of it away. Yeah. So it's kind of the probability, the longevity of the code that you're testing is probably another important thing to consider. If that code is going to run for 10 years and be really important compared to if you're going to run it once. Yeah. For a migration, are you going to test your migration code, or are you just going to run it, verify it worked by eye, and then run it in production and then forget about it? So it's kind of the lifetime's important. And with startups, the lifetime and the risk, you don't know if they're going to survive to get funding in another year. They're going to go down with a crap load of tests. Yeah. Yeah. Thanks, Rich, for writing all those tests for us. That was really, it all worked and nothing broke, but we didn't build enough features.
Took twice as long.
Yeah, it took twice as long. We could have maybe built more features, and maybe one of those features or pivots or whatever would have
saved the company.
Yeah. And so that's, I think for me, because I've been working in startup land, that is their trade-offs. They'll also accept that things might break. Yeah. We released an app for a customer of mine, and he's running a business where people are paying through the app and people are using it, and we've had thousands of bookings come through it. But his tolerance for it breaking is, in my opinion, is quite high. Mm. It hasn't broken much, but if it breaks for a few hours or a day, he accepts that risk because he knows that we're pushing on how much stuff we can build for him. Yeah. And I think that's probably the right call.
Yeah. So I was thinking there actually, as you were saying that, which is more valuable to us, getting new customers with new features or maintaining existing customers with existing features? Yeah. Right? So if you're just in startup mode, you just care about getting features out the door, you need to be focusing on writing the features. If you annoy somebody from the earlier, one of the earlier users, then maybe that's worth it to keep that growth.
Yes.
But at some point, that curve
changes.
flattens out, and then you go, you know what? Now we need to focus on just making sure that all our existing users are happy and nothing breaks for them. And then that's where maybe it changes, right? That you go, well, we now need to focus on code stability more than anything else, more than new features, at which point you start putting more resource towards testing.
Do you know what's hilarious about that is that it directly contradicts I think you're exactly right, but the point we made earlier on of it's a good idea to write the tests close to writing the implementation code.
Yeah.
What you've just described, which is exactly right, and what I think happens in like probably 95% of cases plus, is the exact opposite of that, because you're going to have pushed out all this implementation code with no tests and then go, what we really need now is to make sure this all works. And so now you need to test a thing which you definitely haven't tested. Yeah. And if you haven't tested something, you can be damn sure that it's going to be difficult to test. Sod's law. So.
Yeah, I think it's ironic there, right? And I think you were saying, and it's right. It's really down to where that company that you're working for is at, right?
Yeah.
And I guess another word you might want to say is the culture of the team, right?
The culture's massive. Like if I go and work somewhere as a freelancer, I want to know if they want to write tests. If you ask them, they'll always say yes.
But are they actually writing tests?
The people write tests, and when the chips are down and you use, I'm writing the tests as, and not an excuse, but like as a reason that something's taking longer.
Yeah.
Will they tolerate that? And the answer for most of the clients I work for is no. So then again, that's another reason I don't write tests, is that I think if you work for a really good company who has the requirements where it probably does make sense for them to write tests most of the time, and then does also follow through and write tests.
Yeah.
And there definitely can be big. I mean, I think we're being a bit like putting a bit of a downer on testing, but I think, if you're like Netflix or Google or a bank, you should definitely, and like we've worked in various investment banks and banks, they are a place where I would say in general, it definitely makes sense. They waste a lot of developer time, which basically for them is money, a lot of money, because developers are expensive, on having, an entire team down tools for a week, when they could actually, it's kind of like a debt. I mean, people say technical debt, but it's like a debt, isn't it? It's like if they spent 2 months and said, right, we're going to just make it so we can test everything automatically, and it's going to take one person 1 day to do it. It's currently taking 10 people 5 days to do it, so it's taking 50 days, and we're going to get it down to 1, and it's going to take 2 months to do. That's going to repay for itself really quickly. But so it's kind of like thinking, but then the question is whether there's like the political will in the company to actually put that cash down there and then.
Because the business model will always be like, oh, well, yeah, we should do that, but we've really got this other really important thing to do first. And the prioritization there is tough.
I guess that's the problem, is that to steady the ship like that, you either need to bring more developers in, and we all know that more developers is not proportional to the amount of work you get done. You hire more developers, it doesn't go as quick. But so they can either hire more people in, or they can build less features whilst you're doing the test. So it's either going to cost them money or features. Yeah. Neither of which they'll particularly want to give up. And but this is why, I mean, I think companies asking about, I mean, I think all developers should know how to do it, because there's a time and a place for doing it.
Yes.
And when that comes, I say a lot with the people I've taught to code, I am okay with doing things not like the stamped best practice way, as long as I know how I could do it the best way and I choose not to. I think there's a difference between that and ignorance.
Because I was going to say, like, if you're using JUnit, and so I generally use JUnit and Hamcrest together.
God, I haven't heard that word in a long time. Yeah,
I actually really like it. It makes writing tests,
it's good,
describing tests easier, but every time I do it, because I don't do it that often, there's always that initial learning curve. And I think for somebody being like, I write tests, but I haven't done it for 2 years.
Yeah.
And then to go into somewhere where they're going to be writing a lot of tests, you're going to feel behind, and I feel like it requires more. You need to learn more to write your tests than you do to write the actual code. You've got to be like, so I can, guys, you're teaching, right? I can program now. That's great. And then you're like, okay, chapter 7 is how to write tests.
Yeah,
and they're like, oh my God, this is a whole new thing.
Yeah, it is. It is. You're right. It's definitely like a whole new thing, and you really need to understand how to code properly before you can then even learn to test.
Yeah.
But I think the thing that people get wrong is, I think anybody that has a stance of, you should, and I think there are these people out there, which is basically one of the reasons I wanted to talk about this today. There are developers in the world, and not just one or two, quite a few of them that say, if you don't write tests, then you're not doing it properly. And I think that is very wrong for all the reasons we just discussed. I think if you're in a certain scenario in a certain company with a certain set of economic factors affecting them, then that may be that within that organization, everybody should be writing tests on almost all the code they write, because if it breaks, it's the end of the world, or they lose millions of dollars, or people die because they work for a plane company or whatever. And then, yes, you would be a very bad developer if you went to a company like that and you didn't write tests. But then there's like, you're working for a startup and all you're doing is using up their runway and burning through the cash they have left by writing a load of tests, which are going to basically have zero benefit because you might have annoyed the two customers they have because the system didn't quite work.
Yeah.
But that's completely fine because, someone can call them up on the phone and say, Dave, I'm really sorry that it broke, but don't worry about it. We'll fix it for you. We'll give you a discount. It doesn't matter.
Yeah.
So I think...
I guess the only problem there, I guess, is where that startup ends up doing very well very quickly. It's then switching back to being like, crap, now we need to write loads of tests.
The right way, I've not been on the rocket ship journey with a startup, but it seems from the outside like the right way is to not write the tests, and then once you get that product market fit and the rocket ship starts taking off, you almost need to pretty much rewrite everything or try and retrofit test, which I think we all know in practice is probably not going to go so well. So probably start rewriting bits and testing it. And the growing pains you're going to have during that period are going to be horrendous because you're going to presumably need to build new features and either retrofit or start rewriting bits of your system to make sure it's actually properly robust.
Did I read that? I think Uber basically rewrote, didn't they?
Yeah, I think they did. I heard that they had two factions, one Python and one JavaScript, or maybe it was Python and something.
Right.
And they were certain bits were written in Python and certain bits were written in JavaScript, and they were
fighting.
They were sort of annoyed with one another.
Another thing as well, a company thinking about the quick acceleration then and not being reflected in necessarily the quality of the code is Tesla. I think maybe 2 or 3 months ago, somebody that used to work at Tesla sort of went through and discussed all of the
I think I saw that
what they'd seen whilst they were there, because he'd worked on the software update system or something, and he was basically saying it was stuck together with sticky tape and stuff, and people were very disparaging about it, being like, oh well, this is terrible. And it's like, well, yeah, it's easy now to say it's terrible, but when whoever wrote that, because that was one of their core first features, I think, when the Model S came out.
Yeah.
So they were like, well, this needs to be a day one delivery, right? We need to be able to dynamically update all these car software. So clearly that was let's just get something working and we'll deal with it later. Now, they haven't necessarily dealt with it later. Yeah. But there'll become that point, like you're saying, where they go, right, now we need to rewrite our software update node system. Yeah,
it's a very difficult problem. And I think it's just the main thing for me is just as I've got more into it, I've realised there's a lot more nuance. And it's about, I think the more you can think like a quote business person, that's better. Like if you think, maybe not a business person, but if you think like the person that's paying you to do it, if someone's paying you, or if you're doing it for yourself, then it's easy. But if someone's paying you, you think, how would they want me to act? What's in their best interest? And sometimes the answer is not to write tests. In fact, actually in quite a lot, or you can apply it even by function by function or bit of code by bit of code, where you say this, will take me 10 minutes. This one's going to take me 4 hours. Yeah. Probably not worth it. Like that's not in their best interest, because what they would rather have the additional output of features, and they would probably accept the risk of that bit of code staying untested. And they would probably be all right with that. And, we've got a 20-minute deploy time and everything's automated, so it wouldn't be the end of the world. And it's just like factoring everything in. Yeah, so that's what I was going to chip in with there. So factoring in everything that we've said, or you've said, along with some of the things I've said, I guess. If you were going into a new company then, when would you be shocked about the testing situation, and when would you be impressed by the testing situation across not just like the code tests, but like their infrastructure around testing? I haven't seen anything either way. I've never been anywhere where I've been like, this is appalling, and I've never been anywhere where this is amazing. I've just been like, sort of standard fare, a few tests, pretty undefined, shabby testing, mechanism. It's normally quite bad. But let's just say theoretically both ways. Yeah. So theoretically, you go into company X and you're like,
and you're like, yeah, we do tests, and then you turn up and you go, wow, this is as good as it could be.
Full suite, all three, like system level, integration level, like, stuff's clicking things, and then they've also tested all their like functions, and
you've got the integration sort of suite like spinning up, testing the full back end
overnight. That would be amazing if you went.
But I don't. So the reason I ask you that is because I don't think 100% test coverage would be a marker point for me. I don't think that would be something that they'd say, oh, our coverage is 60%, but we've got all this other stuff. You'd be like, that's still amazing, right? 100% test coverage is, I think, it's like a theoretical goal, but you're never going to get that.
I think you've touched on it a couple of times in this conversation, but I think there's a difference. Both you and I tend to write, or you write a bit of library code, and I write a very small amount of library code. But in general, we're what I would call application developers. We build software that runs and does a thing, and maybe to do that, we may build some library code that might get reused between multiple applications. I think testing application code, and especially like UI code, is a bit, I want to say pointless, but like it depends on what you're doing. But it's definitely, if you're building like if I went into a team that was building a library, say I went to like an investment bank in London, and it was like some core team that were like working on a thing that like 20 other teams in the company used, and they did not have any tests, or they didn't have a very comprehensive suite of tests, actually, I would say, I would be pretty shocked and disheartened and be like,
this is not great.
This is not great. But if I went into a team that was like working with like quite closely with some people that had requirements that were changing all the time, and they'd like hack stuff into, because what their customers really needed was quick response times, and tests hinder quick response times because you're going to have to deliver more, and it's going to take longer to build anything. So then I would probably be like, I guess to answer your question, it would be how the number of tests fits like the equation of whether they should have written tests.
So, like, which you described before, right?
Yeah. It's a complicated equation. I don't know if it can be written down, and it's part of it is to do with probabilities in the future, which really gets like finger in the air. Like, what's the probability that this code's going to change? What's the probability, or even like subjective things like, will Dave be annoyed? Or and some, like, I think that's the reason that software engineering is hard, and computers have not yet been able to do it, and good software engineers, like the best software engineers, are also in a lot of, especially application development, tend to be quite not good with people, but they tend to have at least a base level of empathy, because really what you're trying to do is figure out the stakeholder or the boss or whoever's in charge. You're trying to figure out, like, would Marjorie be annoyed by this decision about to make? If she understood everything that I knew, and I'm acting on her behalf with all of my knowledge, you should try and do the right thing for Marjorie. That's kind of the...
and it just happens to be that a lot of people that are in that position are non-technical people.
Yes.
And therefore don't appreciate tests, and also have never been necessarily enlightened about why testing's a good idea.
But they do care about like how often their system breaks. Although there is a human nature. I don't know what the thing is, but like, people, there's like that thing called the hero anti-pattern, which is like the developer that writes no tests, like messes everything up, but he or she is a hero when it breaks. So they like swoop in and they're like, don't worry, I've got you. And then they're like, Andrew is a great guy because he always saves us, even though it's him that's causing all the problems. So
and also no one on the team gets on with him, and they're like, why are we still employed? Like, well, because when there's trouble, Andrew comes sweeping in, and they're like, and it's that weird how you get friendly or you get well respected by the business owner,
but not the other developers who are like, you're just messing everything up. And then you've got like the developer, that sits there quietly, is not a hero, and their code never breaks. And in some ways they might go unnoticed because it's like,
just works.
Everything's, nothing to report. Everything's just worked. But in theory so there's like a human nature element of it. But I think if they fully understood the situation, they should like the second option more of like, well, it just worked. I didn't even hear about it. It's better than like, oh, this person keeps swooping in and saving everything because they broke it in the first place or because it was broken or rubbish. But it is a very complicated, it's just a very human thing. And definitely anybody that says you should do tests or you should not write tests. Like if you give it either prescription without context, it's got to be wrong because it really must, like, it depends. Like if you're just doing a project for yourself to learn a thing, should you write tests? No, of course not. Like you're just trying to learn a thing. Like why would you waste a bunch of your free time writing tests? So like it just really depends.
And then on the opposite end, you're writing the control system for a new Boeing aeroplane.
Yeah, write tests.
Like,
please write tests.
100%. You're probably going to be like, we can't ship this until it's 100%
and that's
covered.
Completely legit. I think what's happened in the industry is there was a period, and possibly still is a period, where in the scenarios where you should write tests, people didn't.
Yeah.
Because non-technical business people, it appears better to them. And what that's sort of led to is an overcompensation where people have just gone blanket. It tends to be more enterprisey developers or developers that work for bigger companies, but they almost sort of don't think about perhaps these other coding scenarios, and they're like, you should. And I guess the other reason is that they probably work with developers that didn't choose not to write tests because they were making a calculated decision. They just couldn't because they were a bit rubbish. And as you said, writing tests is pretty much, it's towards the end of the learning curve of learning to program.
Yeah.
It's like you need to already know how to program so you can write the implementation code. And then I would say in general, testing tends to be harder than actually writing the implementation code and may affect how you write the implementation code. It's not easy. So I guess that a lot of developers have probably been stuck there with someone who's a bit rubbish.
Because I agree with that point, and I was going to say it earlier actually, but I forgot. A lot of the perhaps slightly older enterprises like the investment banks we've worked at, or the ones I've worked at, they have been through that phase of the business edge pushing them so hard.
Yeah, they didn't write any tests. Probably just for the whole of the 90s.
Yeah. Well, it's sort of like that. And then it's in the culture. And then also they have the problem of like, why? And then the business are like, why is all of the software that the IT department deliver here terrible?
Yeah.
And it's like, well, it's not terrible. It's that, you just have, there were no tests, and now anytime we make any change, it's highly likely to break stuff. And then, so then you end up with the issue like I saw a little bit. My first place is that then every Tom, Dick, and Harry is like, you know what? We're going to fix this. We're going to start again and write a new app.
Yeah.
To do the same thing, and then you have. Yeah,
I love it. I'm guilty of it.
No, and completely makes sense, right? But you have that problem of, well, now we have three things doing the same thing because the original one has been around for 15 years, does everything that everybody wants, and now we're trying to start again. And you can't replace that in any sort of sensible time frame.
Yeah, it's
and like, well, we'll do it right this time, but you never get there because that app never gets accepted, and then you still have the same problem rather than trying to go back and fix the original problem. You're just trying to move. You're just trying to wipe the slate clean and try again, and it just doesn't work. Another
unfortunate characteristic of scenarios where you probably should write tests and perhaps they're not getting written is it's death by 1,000 cuts. So like the first time you don't write tests on a small piece of functionality because the business are like, we need this right now, it kind of makes sense, but then it compounds. It gets worse and worse every time you don't do it. Then you end up in the situation like in my first job where all of a sudden you're like, hang on a minute, a third or like a fifth of our developer time is spent not writing code. It's literally running through an Excel spreadsheet, and then you're like, how did we get here? And they will have got there through, people being aggressive with deadlines. And it's kind of short-termism. And then a lot of companies, the culture is short-term, kind of like how, companies go for quarterly earnings and, everyone complains. They're not thinking about where they're going to be in 3 years. You end up with the same thing with code where it's like, well, there'll be a manager whose career really depends on getting a software project delivered this year. Yeah. And then they'll get the promotion and the test will never get written, and this, they'll have created more costs because you need to hire a testing team every month when you want to release it, but they're not measured. It's it's an imperfect system. They're not measured on all of the things. They're measured really hard on one thing, which was like, did the system get delivered by that date? Yeah. They're not measured on, did you actually increase our software development costs in the long term? And this is going to cost us like 5 million in the next 5 years because now we need a team twice as big. Yeah. Because everything's a mess. So and that's the way these big, the big organizations work, because they're like, we have to be able to measure if somebody's worth being promoted or not. But then that measurement, particularly for software development, is imperfect because they, like you say, they tend to go for
did it get delivered, and was the client happy? Yes or no?
Yeah.
There's a bit more to it, but not much. But actually, objectively saying, is this developer a good developer, is a really hard question to ask.
Yeah.
To answer, right? Because you really only get that from working with, like, if I was working in a team of, say, 10 developers and we're all doing the same thing, which I haven't done for a while, you quite quickly realise, not quite quickly, but you, by the fact that you're just with them and working with them, you get that sense, right? I don't think it'd be very easy to write that down in a paragraph and send it to a manager and be like, this is why he's good.
Yeah, yeah.
Because then it ends up like the system, the two guys we said before, right? You've got the guy that sits there quietly, chatty guy, gets on with everybody, but just never any drama. But when there's a critical issue and, money's flowing out the company, there's this other guy that runs in, fixes it and gets it back. Because that's the only time management are actually noticing the whole team.
Yeah, yeah.
You know what I mean?
Then they broke the thing, they've written a wrong line of code and then it breaks and then they come in and fix it. They're still the hero. They're never going to say, I screwed up.
The people the business know are the people that are there when stuff breaks.
Yeah, yeah.
Because that's when they care. Because other than that...
Outside, out of mind, it's just...
Because other than that, they're like, as long as it arrives...
Who cares?
Yeah. Well, who worked on it? Don't care. But now it's broken. Where's Andrew when we need him? You know what I mean?
I think the only way that these big companies can solve these sorts of problems is we kind of know the sorts of software engineering best practices that teams should be doing, like writing tests and, I don't know, maybe agile depending on it. There's like this certain set, having a good deployment thing, having all these things in place. And you can minimize the cost of software development over like a 5-7 year time horizon by doing these sorts of things, as opposed to like just going for it, writing a bunch of code, then it starts breaking. Now you need to double the size of your team, and then all of it, you can't deliver more features anymore. So there's downsides in like a couple of months or years away. I think if you put someone who knows what they're doing at the helm and then you trust them, that's the only kind of way to, because like you say, it's hard to measure month by month, because if you're thinking about 2 or 3 years down the line, because you get this kind of, the people call it churn, but it's like, you didn't write any tests and then the system gets really big and it's being used by loads of people, and then all of a sudden you want to change like a really small thing and you're like, well, this is just going to break everything, and we can't be sure it's not going to break everything, so it's going to take us like 3 weeks. Whereas a team that had written a full suite of tests would be like, no problem, change it for you in like, half an hour. So
I think that's a lot of it actually when you get to those big systems. I think you just hit it there, it's like, we're not sure. They're like, well, can you change it? Well, we can. You've changed it, yes. And it works in that particular case that you've asked about. But there's 5,000 other people over here that we don't know if it's going to work anymore.
It does give you, I think, a big thing. I think you're right. I think in really big companies, big systems, big teams, it gives you a sense of certainty over quite a large requirement set, maybe is like the way I'd phrase it. But because that's a really common case. Like it worked in this particular case that you asked about. But like, there will be someone in accounting that's using this in a way that no one's aware they're even using it. It's oh god. And then you'll get an email in like 3 weeks being like, oh, this has stopped working, and
Yeah, that's the frustration. It's funny, isn't it? I haven't worked in a company that big for a long time now, and it's weird. It's actually funny thinking back to those situations that we were all in. I was definitely in.
Yeah, it sticks with you, doesn't it?
Yeah, that you're like, these were bizarre situations to get ourselves into.
Yeah, when I was talking to you about the spending a fifth of my working time testing, I literally felt the dread. I hadn't thought about it for years. I felt the dread rising up into my chest.
I was thinking, you must have told me that at the time because we were living together.
We were living together at that point.
But I don't remember the pain.
When you caught me standing on the balcony with my arms outspread, just screaming eagle? That
was then.
That was then. That was a dark time.
I really don't remember. I obviously remember you working a lot, but I had forgotten that entire thing that you were working on there.
There were words I used to describe it, but it was not good.
Yeah.
But I did learn a lot though, and I think the key thing about it's interesting where I trained the guys and I showed them how I think I should do things, which hopefully is pretty decent.
Yeah.
But then one of the things that I think that they still need to get is seeing how to do things badly, because the way that I do things now is almost entirely informed by watching how other people have done things, or myself have done things wrong. You don't learn if you're just in an environment where everybody does, because you don't have that fear. You don't have that feeling of standing on the balcony, ready to leap.
But that's that thing, is that you only see that when you switch, right? We've said before about, switching, having switched jobs a few times, and it's a really big eye opener when you go somewhere else and you see what things people do right and wrong.
Yeah.
And that's how you learn, right? And that's how you, and then maybe having seen that a few times, and I think partially having that course, having that course in our university career, our university fourth year, they were really always about, they were like, testing is the most important thing in the world. So that's your starting point, and then you're like, well, this is clearly over the top.
Common sense.
And then I think over time they sort of come together, and you go, okay, I see what they were saying. Yeah, that was still the theoretical, aim for this. You're never going to get there. But I definitely appreciate tests more. After that course, I didn't really appreciate them at all.
No.
But then over time, I've gone, yeah, if we'd have written tests here, we wouldn't have had this huge problem that we've had. Or when I was at one of the other my old places, I was like, we should just write tests because there's only two of us, and then no one's going to change this again. So it's like, well, let's just write the test, and then it's there. And then when I leave and it's handed over to somebody else, they've got a better leg to stand on.
Yeah, it does. It is helpful for multi-person stuff.
Yeah.
I think it is like a thing where you can protect future someone else, or possibly you. Yeah. I have a memory that lasts about 2 months when it comes to coding. Look at code from 3 months ago. It might as well have not written it. It's basically game over.
I guess one of the things with doing JavaScript, you talked before about the linters that you use to make everyone's code look very similar. But I guess in a lot of places where that isn't the case, you're going to come into code and it be written in a very different way to the way. I mean, even with linters, right? People can still write code different ways to achieve the same thing.
Yes.
And you're going to be like, and I think that's where, I know we joked about it before, but I can imagine where maybe there's a use case for looking at the tests as well, because you're like, this is written in a really weird way. And you're like, I think it does this, but I wouldn't have done it this way. So is it definitely doing that thing?
Yeah.
And then maybe the tests there just validate that that's what you're doing.
Yeah. I think the linter stuff's interesting because it's similar. It's also a check on your code that should probably fail your build and protects people. So it's kind of a similar thing.
Yeah.
But the big difference is that you can set that up once on one project and then you've got it. So the cost is actually comparatively low over time. So if you're going to work on JavaScript for like 3 years and in the first week you're like, I'm going to set up a linter and a prettier that I can then reuse on every single project. And for me, I mean, I had 4 people working on projects for me. So I probably spent, say, like 1 or 2 days refining my sort of lint and prettier thing. And the payoff's been huge. Whereas with testing, it's always bespoke to that bit of code. So the cost is kind of an ongoing, and the cost is deceptively high, basically. That's a big part of the problem. People underestimate it and they say, the frameworks are really good and this is really great. But in a lot of scenarios, it gets tricky. And
I think that's why one of the reasons I ended up open sourcing some of the stuff I've done is because I'm in that, you get into that situation, right, where you've written code and you're like, well, I trust this, whether I've written tests or not. I know that this code does what I want it to do.
If I don't change it, you know.
So then you're like, well, then that's part of my thinking, right? I was like, I've written all this code that we're using day to day in this job. If I open source it, add some tests to sort of prove that it does what I said it does, because I think from an outsider looking in, they're looking for some tests.
Yeah.
Then I think you're in that situation now where I'm like, well, if I need to do this thing again anywhere else, I can take that, and I'm already a week, 2 weeks ahead of if we were just starting from scratch in a new place.
Is there anything else for testing, or do you think we've put it to bed?
Yeah, I think it's a tough one, because I think when we listen back, we're going to have contradicted ourselves a lot.
Yeah. The first half we were like, never write tests. Yeah. The second half we were like, always write tests.
Yeah, but I think that summarizes why it's hard and why it's hard to know when to do and not to do. Yeah. And I think, like you said, the context of the situation is really important. Yeah. And it is really difficult. And I think it's one of those things that there's no right answer. There's no obvious right answer. And that's what makes it tough.
Yeah, it's very context specific.
Yeah.
Like very, very situation on a macro level of what kind of company am I working for, and on a micro level of like this function versus that one, because it's hard. But the formula is always there, and it is about the cost, which is pretty much, the cost is easy to calculate, I think, actually, which is easier, which is how much time, developer time, which basically is proportional to money, is this thing going to take. The benefit is way more complicated.
Yeah, the benefits.
Because in a lot of cases, the benefits are not really there, and that's when you maybe shouldn't write tests. And if the benefits are large on a short or a lot of times the benefits are long term, like we discussed in bigger companies of, over 3 or 4 years, you don't build some system that no one wants to touch and no one can change. So it's thinking about those benefits over like maybe a longer period or possibly even a shorter term thing, and then going, is it worth it? Cost benefit.
It'd be interesting to see if we can try and put the benefit equation into the show notes after this, whether you can sort of formalise it in any sort of way.
We will try.
And we can call it Gill's Law.
Gill's Law. What do I get it? Oh, that would be
nice.
You made up? I think we should call
it
it Marjorie's Law.
Yeah, well, that would be better, actually.
Marjorie's Law would be a better name. Yeah, we'll call it Marjorie's Law, and then we'll have a book published very soon.
Just with that formula.
Just with the formula. I think you could have a go. I think it might get a bit waffly. I don't know if it could be a formula.
Well, that's what I mean, but probability.
Yeah, it might be more like an algorithm. It might be like if the probability of like this thing is too high. But I think it is probably, you could express it as a formula. The hard one's going to be the benefits.
Yeah, that's what I mean. And I think I think you have said it. You said it a couple of times, I think, in this, and I think it's a really interesting way to think about it, because I think the way you verbalised it was probably how I was thinking about it in my head, but I hadn't thought about it in those precise terms, or precise-ish terms.
Precise-ish.
Yeah.
But we'll get Marjorie's Law out to you very soon.
Marjorie's Law. Imagine if we become famous because of that. You'd be so disappointed.
We should have called it Gill's Law. Rajasansi's Law.
No, it perhaps doesn't have the ring.
I don't know though. It's quite a clever surname.
It's too many syllables. That's the problem with it. I think you don't remember laws with names with too many syllables.
No. Yeah, Moore.
Exactly.
Moore's Law, Gill's Law. Marjorie's Law, people would remember.
Mainly for the entertainment factor.
Because it's good.
I don't think there's anybody called Marjorie or younger than 40.
No, you don't meet people called Marjorie, do you? Sort of work. No, maybe at work.
All right. So cool. I think that's it then.
Yep.
Cool.
Exit 0.